Okay, I'm going to talk through this table of scenarios that affect your volume and tonicity, your liquidness and your solidness, or your amount of liquid and your solidness of that liquid. It lines up with this weird box graph, the volume tonicity diagram. So I'm just going to explain the scenarios. It's all about this relationship of liquid versus solid, aka water versus salt, aka volume versus tonicity or osmolarity. Tonicity and osmolarity are the same thing, basically. So yeah, it's going to be about water versus salt, and you basically need to categorize each of these boxes according to water versus salt, and according to what you're gaining versus or whether you're gaining or losing. So that's another relationship that is crucial here. Gain versus lose. You're just going to choose one of these words, gain or lose, water or salt, for each of these boxes, and then it makes it make sense, and it makes it easy to make sure you're doing the right thing. This is another relationship that's important here: water versus salt water, or I would say pure water versus salt water. Pure water versus salt water. This is a very important relationship, or very important contrast that I'll explain in all of this renal stuff. Yeah, because it's a different thing. It's just important to remember your body is not full of water. Your body is full of salt water, right? Normal saline, right? It's salt water. That's what saline means. That is the default. Pure water is not the default in your body. So with that being said, I'll start from the top. Ingest water. So ingest obviously means gain, not lose. So you're gaining something. What are you gaining? Pure water. So that's going to increase your volume because you're gaining volume, right? In fact, that's what I should put here instead of what I put here. I should put gain. And here I should put lose. Good. Anytime you gain something, you're going to have increased volume. Anytime you lose something, it's going to be decreased volume. So you gained water. That's going to make you more watery, not more solidy, right? So you're going to have decreased tonicity. More watery versus more salty, or solidy, but another way to word it is more salty. Okay, because salt is the solid that we're talking about here, and water is the liquid. So next up, infuse normal saline, right? You're gaining salt water. So because you're gaining something, it's automatically increased volume, right? So we know how it affects the volume. Now, how does it affect the osmolarity? Well, you didn't give salt, you didn't give water, you gave salt water, which is the normal stuff in your body. Your blood is salt water. So it's not becoming more watery or more salty. It just stays normal. The tonicity just stays normal. So that one is checked off. Let's do our check marks as we go. Okay. Check, check. Next up, we infuse hypertonic saline. So we're gaining salt water, but it's salt water that's too salty, right? It's hypertonic. So we're effectively gaining salt, right? Because we're gaining more salt than water. Because this is not normal salt water, this is hypertonic, extra salty salt water. So because we're gaining something infused, we automatically have increased volume. How does it affect osmolarity? We gain salt, so it's going to be more salty, increased osmolarity. Check. Next up is this, normal volume. That means we're not gaining or losing any volume, right? And the only way that happens is when we, we'll see. Here it says you sweat, then drink the same volume of water as the amount that you sweat. So there's two things happening here. Sweat, that means losing salt water, right? Then drinking the same volume of water, that means gaining pure water. So you lose salt water and gain pure water. Because you lose and gain, the volume is unchanged. It doesn't go up or down. But because you lost salt water and gained water, you effectively just lost salt, right? Because the water you lost was replaced, but the salt wasn't. So if you lose salt, you lose solid, you become more watery, right? And less salty. Check. Now over here, this is normal state. Your body should have normal osmolarity and normal volume. Good, when nothing's happening. That's a scenario where nothing's happening. Next up, ingest salt tablets. You don't even need the words tablets. Ingest salt, that's what they're saying, right? You gain salt. Obviously, you're going to be more salty in your osmolarity. How's your volume affected? It's not affected at all because you didn't take in any water, right? You didn't gain or lose water. So you have normal volume. Check. Next up, lose more salt than water. Okay. They said lose more salt than water. So effectively, you're losing salt. So if you're losing salt, you become less salty. That means you become more watery, right? You're becoming waterier, not saltier. When they say lose more salt than water, you still did lose some water. So, of course, lose water means lose. You're going to have less volume. So you automatically have decreased volume. Check that. So it's like you were losing salt water. See, but you lost way more salt. So it's salt with water in parentheses. You were losing salt water, but you mainly were just losing salt. Check. Next up, losing blood, which is hemorrhage, bleeding, right? Or losing lots of poop, which is diarrhea. So your blood is salt water, and your poop is salt water, right? Any bodily fluid that's like from your body is going to be salt water. And it's going to be, normal saline salt water. It has that normal amount of saltiness that your body likes. So because you lost salt water, right, normal saline, you lost both salt and water in equal amounts. So you're not becoming more watery or more salty, right? Your tonicity is going to stay normal when you lose salt water. But because you were losing something, right, you were losing, water, salt water, your volume is, of course, going to be decreased because you lost something. You lost volume. But your tonicity is unchanged because you lost salt water. You didn't lose pure salt or pure water. So diarrhea and hemorrhage are both normal tonicity. Then last, we have dehydration and diarrhea. See, when we first got this table as a class, I didn't even realize these were like two different things, hemorrhage and diarrhea, because they don't put bullet points on it. So that's what this video is for. Try to make it clear. So these are two scenarios: dehydration from sweating and diarrhea in an infant. So babies are different from adults. Babies don't poop salt water. They poop out pure water, basically. That's oversimplification, but that's basically how I remember it, because babies are basically just sacks of water. That's like my whole mnemonic for babies. They're basically just sacks of water. Their bodies have so much water that the rules are different for them as far as like stuff like this, right? A baby is just a sack of water. And that's what this drawing here is showing. So because a baby is just a sack of water, they poop out pure water. And when you sweat, it's pure water. See, that's the thing. You're like, what? I thought, I thought that sweat is salt water. That's like how you think of it as a layman. But basically, long story short, your sweat is not, I don't remember the exact reason why, like the trick to it or whatever. Like maybe like, oh, the freaking water evaporates, but the salt doesn't evaporate, so it stays in your body. I don't know what the reason is, but you should just think of it in medical terms. Your sweat is not actually salt water like people think it is. Your sweat is effectively just pure water, okay? So in both of these situations, losing water just by being dehydrated and not drinking enough, or by sweating too much, you're losing pure water. And if you're a baby and you're pooping out, remember babies poop out pure water. So you're losing water. So because you're losing something, that word lose automatically means you have decreased volume. And then because you're losing pure water, of course, you're going to become less watery and more salty. So that's the last scenario checked off. And that's it. And then I could quickly show the scenarios on the graph. Like, let's do it in order of the letter. So for A, you're losing salt water. Your tonicity is the same, but your volume goes down. Let's look at the graph. A, right? You're losing volume, right? So it's not wide. This purple stuff is not wide enough to fill the box because it has a low volume, but your tonicity stays the same. So the purple stuff is not taller than the box, and it's not shorter than the box. It's the same length as the box. I'm actually not going to go through the graph because I have another video for the graph, and it makes it all clear. It's just a different way of showing the same thing. So that's it.